Happy Halloween, and welcome to this, our spookiest of robot tutorials. I'm Daniel, you know me from 2016 in West Africa, and I'd like to say hello to everybody in Togo and in Ghana. Today we'll be talking about testing, and I'd like to show you something very exciting. This is the prototype robot that we'll be building with you when we come to Accra and Lomé. And this robot is a prototype. That means it works and all of the sensors are connected, as are the servos and the processors and etc. But it's still a prototype. Now we're moving into the stage of making this prototype robust enough for what we would call operations. When you have a prototype, often it'll do the things that you want it to, but it's not quite robust enough for what you want to use it for. So you need to make improvements in the background without losing functionality. In the world of software development, which is where I normally work, we would do this with unit tests. So you take a unit of software, normally all units if you can, and you test that it delivers the expected results with expected inputs. This is a little bit more complicated with robots because robots can't just take data and process it and produce outputs. They interact with the real world, and the real world is kind of messy. I've tried to preserve the principle of software testing though here, because it'll give us a clean approach to verifying that the robot does what we want to do, or what we want it to do. In the world of software testing, I would give it always the same inputs and expect always the same outputs, and therefore no human interaction would be required at all. Because this is a robot that interacts with the real world, as I said, there will be some interaction, but I've managed to write some tests which are restricted to only verifying that the test conditions are met before the test starts, and that the test executed correctly at the end. There are a total of 4 tests: the test of moving back and forth, driving in an arc, so driving and curving at the same time, detecting obstacles, that's what the ultrasonic sensor in the front of the robot is for, and turning without driving. So let's see what the results are. I'm going to execute the test suite, and first the test suite opens up the drive test and asks me to make sure that the ground in front of the robot is clear so that it can move back and forth. It is, so I press enter. And the robot did it successfully. The next test is the arc test. It asks me to clear the ground in front of the robot and to the right. Now this test is running using the cord. That's just so I don't drain my batteries too much. It would be easier if the robot weren't attached to the wall, but we'll make do. I just don't want it to run over the cord. So I'm going to execute the test. Okay, that worked well. The next test is the ultrasonic test. So I'm supposed to place an obstacle within 20 centimeters of the robot and press enter, with the result that an obstacle is detected. I do detect an obstacle. Now I'm supposed to check that no obstacle is detected when none is present. That worked as well. No obstacle is detected. So now the turn test. The robot's going to rotate on its axis without driving. Okay, all the tests completed successfully. As you can see here, the output of the test suite is only a record of saying, is the test condition met and did the test execute properly? And that's really all you want to see with the test suite, that the test executed properly, or if an error arose, where the error took place. So now that we've done this, I can continue to write the software and improve it in the background with the knowledge that I'm not breaking any of the necessary functions that the robot has. I'm looking forward to trying this out with you in West Africa. See you in December.